Hello friends, this is Rashmi Singh and welcome to my channel Unraveling Science. Today's topic is motion, class 9, chapter 8. What is motion? It is the location of an object changes with time. The object is said to be in motion. So we can say a body is said to be in a state of motion when its position changes continuously with respect to a point. Similarly, a body is said to be in a state of rest when its position does not change with respect to a point. Types of motion. Motion can be of different types depending upon the type of path by which the object is going through. First is circular motion in a circular path, as shown here in the picture. Second is linear motion in a straight line path, as shown. And the third one is oscillatory or vibratory motion, that is to or fro path with respect to the origin, just like a pendulum. Motion in a straight line. Motion in a straight line, distance and displacement. Distance. The distance covered by an object is described as the total path length covered by an object between two endpoints. As you can see here, the blue line represents the distance covered by the object, whereas displacement is the shortest possible distance between the initial and the final position of an object. So the green line shows here the displacement of the object. So here you can see the path taken by the green line shows the distance, which is total equal to 70 kilometers, while the blue part shows the displacement, which is 14 kilometers. Scalar and vector quantities. Scalar quantity, it is the physical quantity having its own magnitude but no direction. Example, distance and speed. Vector quantity, it is the physical quantity that requires both magnitude and direction. Example, displacement and velocity. Zero displacement, when the initial and the final position of an object are same, the displacement is zero. So here you can see the blue line represents the distance covered by the object, that is 80 kilometers, and the displacement here is 0 kilometers. Difference between the distance and displacement. Distance is the length of the actual path traveled by an object. Displacement is the shortest length between initial and final position of an object. Distance is a scalar quantity, displacement is a vector quantity. Distance is always positive, displacement can be positive, negative or zero. To calculate distance, direction is not taken into account. To calculate displacement, direction is taken into account. Uniform and non-uniform motion. Uniform motion. So as you can see here, the cyclist travels 10 km in the first hour, then again 10 km in the second hour, and so on. Thus it shows a uniform motion. So when an object travels equal distance in equal intervals of time, the object is said to have a uniform motion. So the graph formed between distance and time in uniform motion is a straight line graph. Non-uniform motion. Now in this case, the cyclist traveled 20 kilometers in the first hour, then 5 in the second hour, then again 5 in the third hour, and then 10 kilometers in the fourth hour. So you can see he is traveling different distance in every hour. So the motion is non-uniform motion. So when an object travels unequal distance in equal intervals of time, the object is said to have a non-uniform motion. The graph formed in non-uniform motion is not a straight line graph. Speed. The speed of an object is defined as the distance traveled by the object per unit time. Speed is equals to distance upon time. SI unit of speed is meter per second. If a body is executing uniform motion, then the speed will become constant. If the body is executing non-uniform motion, then the speed will not remain constant but have a different value throughout the motion of the body. So for non-uniform motion, average speed will describe one single value of speed throughout the motion of the body. So we can write average speed is equals to total distance traveled upon total time taken. An easy way to remember the formula to use speed, time and distance triangle is, you can see here distance is on the top, then speed and time are bottom. So from this we can get distance is equals to speed into time, speed is equals to distance upon time, and time is equals to distance upon speed. Let's take an example. Suppose an object travels 16 meters in 4 seconds and then another 16 in 2 seconds. What is the average speed of the object? So the total distance traveled by the object is 16 plus 16, that is 32 meters. Total time taken will be 4 plus 2, that is 6 seconds. So the average speed of the object is 32 upon 6. Total distance upon total time. So 32 upon 6 will be equal to 5.33 meter per second. Speed with direction or velocity. Velocity is the speed of the body in a given direction. Velocity is equals to displacement upon time. Velocity is a vector quantity. Its value changes when either its magnitude or direction changes. For non-uniform motion, average velocity will be calculated in the same way as done in the average speed. Average velocity is equals to total displacement upon total time. So for uniform motion, the average velocity can be calculated as average velocity is equals to initial velocity plus final velocity upon 2. So we can write average velocity is equals to v plus u plus v upon 2. U is the initial and v is the final velocity. SI unit of velocity is also meter per second. Velocity can be positive, negative or 0. Example. Usha swims in 90-meter long pool. She covers 180 meters in 1 minute by swimming from one end to another and back along the same straight path. Find average speed and average velocity of Usha. So the total distance covered by Usha in 1 minute is 180 meters. Displacement of Usha in 1 minute is 0 meters. Average speed will be total distance upon total time. Total distance here is 180. Total time here is 1 minute is 60 seconds. So that will be equals to 3 meter per second. Average velocity is equals to displacement upon time. So displacement here is 0. So we can write 0 upon 60 seconds, that will be 0 meter per second. So the average speed of Usha is 3 meter per second and average velocity of Usha is 0 meter per second. Acceleration. For uniform motion, in case of uniform motion, the velocity of an object remains constant with change in time. Hence, the rate of change of velocity is said to be 0. For non-uniform motion, in case of non-uniform motion, the velocity of an object changes with time. This rate of change of velocity for unit time is called acceleration. So acceleration can be written as change in velocity upon time, which is equals to v minus u upon t, where v is the final and u is the initial velocity, t is the time. SI unit of acceleration is meter per second square. Uniform acceleration: an object is said to have uniform acceleration if it travels along a straight path, its velocity changes, increases or decreases by equal amounts in equal time intervals. For example, the motion of a free falling body. Non-uniform acceleration: an object is said to have non-uniform acceleration if its velocity changes, increases or decreases by unequal amount in unequal time intervals. For example, if a car is traveling on the road with unequal speed in unequal intervals of time. Acceleration is also a vector quantity. If the direction of the acceleration is in the same direction as that of the velocity, it is called positive acceleration. If the direction of acceleration is in the opposite direction as that of the velocity, it is called negative acceleration. Negative acceleration is also known as deceleration or retardation. Example: starting from a stationary position, Rahul paddles his bicycle to attain a velocity of 6 meters per second in 30 seconds. Then he applies brakes such that the velocity of bicycle comes down to 4 meters per second in next 5 seconds. Calculate the acceleration of bicycle in both the cases. So in the first case, initial velocity u is 0, final velocity v is 6 meters per second, time is 30 seconds. So we know that acceleration is equals to change in velocity upon time. So putting the values, we get 6 minus 0 upon 30, that will be equal to 0.2 meter per second square. In second case, initial velocity is 6, final velocity is 4, time 5 seconds. So now the acceleration will be 4 minus 6 upon 5, that will be equal to minus 0.4 meter per second square. Graphical representation of motion. Distance time graph. It represents change in position of an object with respect to time when the object is in stationary position. As you can see here, if the distance is constant at all time intervals, straight line graph parallel to x-axis is formed. When the object is in uniform motion, during uniform motion, equal distance is covered in equal interval of time, thus a straight line graph is formed. When the object is in non-uniform motion, during non-uniform motion of an object, different types of graphs are formed as per the motion of the body. Velocity time graph. For uniform velocity, straight line graph is formed. Velocity is always parallel to x-axis. For uniform acceleration, straight line graph is formed. For non-uniform velocity and non-uniform acceleration, graphs can have different shapes as shown here in the picture. Calculating the displacement from velocity time graph. Consider the graph given below. The area under the graph gives the distance traveled between a certain interval of time. Hence, if you want to find out the distance traveled between the time intervals t1 and t2, we need to calculate the area enclosed by the rectangle ABCD, where area of ABCD is equals to AB into CD. Similarly, to calculate the distance traveled in a time interval In case of uniform acceleration, we need to find out the area under the graph as shown in the figure. So to calculate the distance between time intervals t1 and t2, we need to find the area represented by A, B, C, D, E. So area of ABCDE is equals to area of rectangle ABCD plus area of triangle ADE, which is equals to AB into BC plus half AD into DE. Equations of motion. The equations of motion represents the relationship between an object's acceleration, velocity and distance covered if and only if the object is moving on a straight line path and the object has a uniform acceleration. Three equations of motion. The equation for velocity time relation. V is equals to u plus at, where v is the final velocity, u is initial velocity, a is the acceleration and t is the time. Second is the equation for position time relation. S is equals to ut plus half at square, where s is the distance travelled in time t. Third is equation for position velocity relation. V square is equals to u square plus 2as. Now graphical derivation of equations of motion. As you can see here, suppose a body has an initial velocity u, that is the velocity at time 0 seconds at point A, and this velocity changes to v at point B in t second, that is the final velocity will be v. So acceleration here will be final minus initial velocity upon time, which is equals to v minus u upon t. It can be written as at is equals to v minus u. So from this we get v is equals to u plus at. That's our first equation. Second equation is s is equals to ut plus half at square. So for this, the distance travelled by the object is equals to area of OABC trapezium, which is equals to the area of rectangle OADC plus area of triangle ABD, which is equals to OA into AD plus half AD into BD. Now putting the values, we get u into t plus half t into v minus u, which is equals to ut plus half t into at, as at is equals to v minus u. So now we get s is equals to ut plus half at square. This is our second equation of motion. Now the third equation of motion, v square is equals to u square plus 2as. The distance travelled by the object in time t moving under uniform acceleration a is given by area enclosed within the trapezium OABC under the graph. That is, S is equals to area of trapezium OABC. As you can see here, we know that area of trapezium is equals to half into sum of the parallel sides multiplied by height or distance between the parallel sides. So that will be S is equals to OA and BC, which are the parallel side, multiplied by the distance between the parallel side, that is OC upon 2. Now substituting these values, we get S is equals to u plus v into t upon 2. From velocity time relation equation, v is equals to u plus at, we get t is equals to v minus u upon a. Now substituting the value of t in previous equation, we get S is equals to v plus u, v minus u upon 2a. Now 2as is equals to v square minus u square. So v square is equals to u square plus 2as. This is our third equation. Example. A car accelerates uniformly from 18 to 36 km per hour in 5 seconds. Calculate the acceleration and the distance covered by the car in that time. So now given u is equals to 18 kilometer, which is equals to 5 meter per second, and final velocity is 36 kilometer per hour, which is equals to 10 meter per second. Time is 5 seconds. So we know acceleration is change in velocity upon time. So 10 minus 5 upon 5 is equals to 1 meter per second square. Now the distance covered by the car in that time will be s is equals to ut plus half at square. So putting the values, we get s is equals to 25 plus 12.5 meter, which is equals to 37.5 meters. Uniform circular motion. If an object moves with a constant velocity along the circular path, the change in velocity occurs due to change in direction. Therefore, this is an accelerated motion. Consider the figure given here and observe how the direction of the object vary at different locations on a circular path. Uniform circular motion. It is the motion when an object travels in a circular path at a uniform speed. For example, motion of a satellite in its orbit and motion of planets around the sun. Velocity of uniform circular motion. Velocity is equals to distance upon time. Here the distance is the circumference of the circle upon time. So now velocity will be 2 pi r upon t, where r is the radius of the circle. Thanks for watching. Please do like, share and subscribe.